flip the page and look at number 9. We have ketorolac tromethamine, 60 milligrams per 2 ml. Okay, so grams over milliliters. Remember, this is our base formula. We got our milliliters right there, but this is in milligrams. We need to convert it to grams. Move the decimal 3 to the left. So 0.060 divided by 2 is 0.03 times 100 equals 3%. And we have grams and milliliters. We have solid and liquid, so weight and volume. Now remember, if this happened to be milliliters, it would be volume and volume. But since it's not, and we're dealing with a solid and then a liquid, it's going to be weight and volume. Okay, let's take a look at a couple of the other different problems. Number 15. Calculate the amount of drug in milligrams for the following dispensed containers. Turconazole 0.8%, and it's a 20-gram container. So we are looking for the amount of drug. We're not doing percentage of strength now. We're going back to our proportions, and we're looking for milligrams. But remember, we're working with grams, so we're going to have to convert it when we're done. So X is going to be in grams for the time being. If you need a reminder to convert, you can always put that in parentheses just to remind yourself. But the base amount we're working with is 20 grams over 0.8 over 100. Because we're looking at 0.08 percentage of 100. So this is always going to be 100, whether it's in grams or whether it's in milliliters. So now we're ready to solve for X. Times 8, 160 divided by 6, or divided by 100, excuse me. So X is equal to 0.16 grams. But remember, we need to convert it to milligrams. So we're going to move it 3 to the right, 1, 2, and 3. So X actually equals 160 milligrams. Okay, number 18. Let's do 18. That one looks a little bit different. Ketoconazole, 2%. And it comes in a 7 fluid ounce shampoo. So right now it's listed in fluid ounces. We need to convert that to milliliters because that's what we're going to be working with. 7 times 30 milliliters per ounce. So we have 210 milliliters. Alright, so we know we're solving for milligrams, but we have to do it in grams to begin with. 210 milliliters is the package size, and we have 2% of 100, so we're going to have 2 grams over 100 milliliters, because remember, this is a liquid, so this has to match as well. We have to have the same units of measure. So now we have our proportion set up. We can solve for X. 210 ml. These cancel. The milliliters will cancel. 210 times 2, 420 divided by 100, and X is going to equal 4.2 grams. But remember, we need to convert it to milligrams. Move it 3 to the right, 1, 2, and 3. So we're going to add 2 zeros. So our final answer is going to be X equals 4,200 milligrams. Okay, let's look at number 25, which is a story problem. Calculate the amount of medication in the following doses. You have found a 300 milliliter bottle of 7.5% solution on the shelf. If the dose is 1 teaspoon, how many milligrams are in one dose? So we are looking for milligrams. First thing, it's in 1 teaspoon. We want to convert that into milliliters. So that's going to be 5 milliliters. That's what we want to use. But we're looking for milligrams. Remember, we can't do it in milligrams. We have to do it in grams. So let's set up a proportion in grams and remind ourselves we're going to have to convert that when we're done. So we're going to have grams over our dose, 5 ml. And we have our percentage, 7.5 over 100. And this is going to be grams. And of course, since this is a liquid, this has to be a liquid too. This has to be milliliters. So now we have our proportion set up. We can solve for x. .5 times 5, 37.5, divided by 100. And x is going to equal 0.375 grams. But remember, we have to convert it to milligrams. So we're going to move it 3 to the right. 1, 2, and 3. So it's 375 milligrams is equal to x. Okay, let's do one more, number 27, because that one looks slightly different than some of the other ones. How many milligrams are in 0.5 ml of a 1/1000th solution? Okay, so what we're looking for again are milligrams, but remember we have to do our proportion in grams and then convert over the amount that we have, 0.5 ml. And we have a proportion. Remember these, a ratio. Remember these ratios can be written as fractions. Making sure that our units of measure line up. Of course, anytime it's written as a ratio, it's always going to be grams and milliliters. Making sure they match, and they do, so we can solve for x. The milliliters are going to cancel out. 1 times 0.5 divided by 1,000, and x is going to equal 0.005 grams. But remember, we need to convert to milligrams, so we're going to move 3 to the right. 1, 2, and 3. So x is going to equal, 0.5 milligrams. Okay, let's do one more. Let's look at the next page, 184, and let's look at number 33. How many grams of sodium chloride are in the following volumes of normal saline? 0.9%. And normal saline is 0.9%. And it says, the question is asking us how many grams. So we're going to be solving for grams. That's going to be our variable. And 33 has 100 mLs listed as the amount. So that's going to go on the bottom. That's the desired dose. And looking at the normal saline, it's 0.9%. Remember, we're going to write that as a fraction of 100. That's a gram, that's a milliliter, so our units of measure match up. We can solve for x. The milliliters are going to cancel out. 100 times 0.9 divided by 100, and x is going to equal 0.9 grams. Okay, so hopefully that helps clear up any questions you guys may have had from reading it and working out the problems. Go ahead and finish working out the rest of the problems. If you have any questions, post those to the Q&A discussion thread or to the virtual office.